Welcome back to the Science Hub SKB with Miss B. Part 2. The Behavior and Properties of Light. In this section, we will be studying shadows, eclipses, reflection, refraction, and lenses. What are shadows? Have you ever tried to outrun your shadow? Or have you ever tried to jump over it? What about when your shadow plays magic tricks with you and seems to disappear? Why is this? Well, the reason for this is that shadows stay attached to you because they depend on the position of the light source and you as the blocker. Your shadow is a projection of you. You can't escape it because it moves with you once the light source stays constant. As shadow seems to vanish based on the angle at which the light is striking upon you. Shadows shrink to almost nothing when the light is directly above you. What are shadows? Shadows are dark areas created when an object blocks the path of light. Light travels in straight lines, which is a property called rectilinear propagation. So, when it encounters an opaque object, it cannot pass through it, and it forms a shadow. Do shadows move? Shadows move based on the position of the light source being projected on the object. For example, the sun changes position throughout the day. As the direction from which the sun's light reaches the object changes, the shadows change in direction, length, and shape. Why do shadows exist? An opaque object is a material that does not allow any light to pass through it. For example, a tree, a car, a stone, and walls. Basically, anything that is not made of transparent or translucent materials and you. When light hits transparent objects, it allows light to pass through them completely so you can see clearly through them. Examples of transparent objects are clear glass, clean water, transparent plastic wrap, and eyeglasses, lenses. When light hits translucent objects, it allows some light through, but not all, creating faint shadows. They scatter light, so you cannot see through them clearly. Examples of translucent objects are a plastic bag, frosted glass, tracing paper, wax paper, and tinted windows. Shadow hand puppets. The art of making hand puppets via the manipulation of shadows is quite fun and engaging. Your hand is opaque, and this can be achieved if you place it in front of a lamp or candle, which are both luminous objects. When a shadow is formed from a point source, you get a shadow that is equally dark all over, and it has sharp edges. This is called the umbra. When a shadow is formed from an extended source of light, you get a shadow that is dark at the center and not so dark at the edges. The darkest area is called the umbra, while the gray area is called the penumbra. In summary, light is able to pass through objects which are transparent and translucent, while light cannot pass through opaque objects. Eclipses. Imagine standing under the vast sky, watching the sun shine brightly or the moon glow softly at night. Suddenly, something magical happens. The light starts to fade, and the sky transforms into a spectacle of shadows and light. This enchanting phenomenon is called an eclipse, where the sun, moon, and earth align in perfect harmony, creating a dance of cosmic shadows. Eclipses are nature's way of reminding us how beautifully connected the universe is. Well, it's the moon casting a shadow on Earth during a solar eclipse, or the Earth casting its shadow on the moon during a lunar eclipse, these rare events are like celestial performances that inspire awe and curiosity. Eclipses occur when the Earth, Sun, and Moon are in a special position in relation to each other. A solar eclipse occurs when the Moon's orbit takes it directly between the Earth and the Sun. The parts of the Earth in total shadow, umbra, experience a total eclipse. Those parts in the penumbra experience a partial eclipse. The moon is a non-luminous body. It reflects light from the sun. A lunar eclipse occurs when the moon passes behind the earth and into its shadow. This happens when the earth is directly between the sun and the moon. The moon looks red during a total lunar eclipse because of a phenomenon called Rayleigh scattering, combined with the way Earth's atmosphere bends sunlight. Some sunlight passes through Earth's atmosphere and is bent around the edges of the Earth toward the moon. As sunlight passes through the atmosphere, the shorter blue and violet wavelengths are scattered out. This is the same reason why the sky is blue, while the longer red and orange wavelengths pass through more easily and get bent towards the moon. The red light illuminates the moon, giving it that reddish or coppery appearance, often called a blood moon. The exact color of the moon can vary depending on the amount of dust or pollution in Earth's atmosphere, recent volcanic eruptions, and the cloud cover. Comprehension. Categorize the following as either opaque, transparent, or translucent: plastic bag, a rock, glass, wax paper, a ceramic pot, a puppy, frosted glass, acrylic, a tree, pure water. Did you get these right? Great job! Why do shadows exist? Shadows are formed because light travels in straight lines and cannot pass through opaque objects. When an opaque object blocks the path of light, it prevents the light from reaching the surface behind it. As a result, a dark area known as a shadow is created. This shadow is simply a region where the light has been blocked, and thus less or no light is present. What is the darkest part of a shadow called, and what is the lightest part of the shadow called? The darkest part of a shadow is called the umbra, while the lightest part of the shadow is called the penumbra. When the moon blocks the sun from the earth, it is called a dash eclipse, but when the earth blocks the sun from the moon, it is a dash eclipse. Correct. Did you get these answers right? A dash moon appears when there is a total lunar eclipse. This is caused by dash scattering combined with how Earth's atmosphere bends light. Red and orange light have dash wavelengths which pass through Earth's atmosphere and bends around the Earth towards the dash to give it that reddish, copperish color. Did you get these answers? Good job! Reflection. Reflection of light. There are two main types of reflection of light. We have regular reflection or specular reflection, and this occurs on smooth, shiny surfaces like mirrors or calm water. The light rays bounce off at the same angle, creating a clear image. And we have diffuse reflection. This happens on rough or uneven surfaces like paper, wall, or fabric. The light rays scatter in many directions, so no clear image is formed. When light travels to a shiny or glossy surface, like a mirror, it bounces off of it and into your eyes. We say that the light has reflected. This is how you are able to see your own reflection in a mirror. Your reflection is referred to as the image. Here are some facts about images that are formed in a plane mirror. 1. The image is the same size as the object. So your image will be the same size as you. 2. The image is the same distance behind the mirror as the object is in front of it. Therefore, if you are 1 meter in front of the mirror, your image is 1 meter behind the mirror. Hence, your image will be 2 meters away from you. 3. The image formed is laterally inverted. This means that the left side of the object is the right side of the image. And 4. The image is virtual. The term virtual is used to describe an image that does not actually exist but appears to exist at some point. Virtual means not real. Reflection of light. You can see reflections of yourself in mirrors and pools of water. The following are some devices that make use of plane mirrors. 1. Cars, to see the behind of the car. 2. Periscopes, to see above tall objects used in submarines. 3. Traffic, used to help drivers see around corners. The laws of reflection of light. There are 2 laws of reflection. 1. The angle of incidence is equal to the angle of reflection. And 2. The incident angle, reflected angle, and the normal all lie on the same plane. Comprehension. Explain what the reflection of light is and what are the 2 types of reflection. The reflection of light refers to light bouncing off of shiny or glossy surfaces. There are 2 types of reflection: regular or specular reflection and diffuse reflection. Your reflection is an dash of you. In a plane mirror, it is the dash size as you. It is dash, inverted, and it is upright, hence it is not real and dash. If you are 2 meters in front of a mirror, then your image is dash meters away from you, because images are the same distance away from the mirror as the object is away from the mirror. Did you get them right? Yay! Very good. Your reflection is an image of you. In a plane mirror, it is the same size as you. It is laterally inverted and it is upright, hence it is not real, therefore it is virtual. If you are 2 meters in front of a mirror, then your image is 4 meters away from you, because images are the same distance away from the mirror as the object is away from the mirror. Where can you see reflections of yourself? And list some devices that work based off of reflection. You can see your reflection in mirrors, pools of water, backs of spoon, etc. Car mirrors allows the driver to see behind them, periscopes allows the viewer to see above tall objects, and traffic allows drivers to see around corners. State the 2 laws of reflection. 1. The angle of incidence is equal to the angle of reflection. And 2. The incident angle, reflected angle, and the normal all lie on the same plane. Refraction. Refraction is the bending of light passing from one medium to another. The word medium refers to materials or substances like air, glass, or plastic. For example, light bends when it passes from air to water. Here, air and water are mediums. Light also slows down when it passes from a less dense medium to a more dense one. Air is less dense than water. Light slows down because it interacts with the electrons of the medium it is passing through, and this excites them and causes them to move about. This in turn becomes an obstacle and slows down light. Objects appear bent in water because light changes direction when it moves from one medium to another, in this case from air to water. Our eyes perceive that light always travels in a straight line, so when light bends, it tricks our brain. That's why objects appear closer to the surface than they really are, and objects appear bent. In summary, objects look bent in water because light bends when it moves from water to air. This is called refraction. Our eyes perceive light as always traveling in a straight line, so when the light bends, it creates an optical illusion. What we are actually seeing is an image of the object formed by the bending of light. The image produced is located higher than the real object, producing that signature broken bent object look. A rainbow is created when white light from the sun is refracted by water droplets in the air. For a rainbow to appear, two things must happen. There must be rain or mist in the atmosphere, and the sun must be shining, not covered by clouds. When light passes through a prism, it slows down, bends, and spreads out into its 7 different colors. This is another example of refraction. Red light bends the least, while violet light bends the most. Sir Isaac Newton was a scientist who studied light. Newton took it a step further to prove that visible light was only composed of 7 different colors. He passed each of the colors separately through another prism to see if it would further split into more colors. To his benefit, it did not. The laws of refraction of light. There are 2 laws of refraction. 1, the incident ray, the refracted ray, and the normal all lie in the same plane. And 2, Snell's law. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant for a given pair of media, where n1 sine theta 1 is equal to n2 sine theta 2. N represents the refractive index of the media, and theta represents the angle of either incidence or refraction. Comprehension. Explain what the refraction of light is and when does refraction occur. Refraction is the bending of light. Light bends when it passes from one medium to another. For example, light bends as it passes from air to glass. Read the statement below, then answer the questions that follow. When light passes from air to glass, it slows down. List the mediums mentioned in the statement. And why does light slow down in glass? The mediums listed are air and glass. When light enters a medium, it induces oscillations in the medium's particles, in this case the electrons. These particles act like little antennas as they re-emit electromagnetic waves. This continual absorption and re-emission of light energy by the electrons in the medium make the wave appear to slow down. Why do objects appear bent in water? And what 2 things must happen for a rainbow to appear? How many colors is white light composed of? When light bends in water, it produces an image in the water that is higher than the actual object. The sun must be out and water must be present, whether in the form of mist, rain, or humidity, for a rainbow to appear. White light is composed of 7 different colors. Who was the scientist that discovered that white light was made up of many colors, and how did he prove this? Sir Isaac Newton is the scientist who discovered that white light is made up of many colors. He used the prism to break light up into its 7 different colors. Lenses. What is a lens? A lens is a piece of specially shaped transparent material that can form focused images of objects. Why do we use lenses? Lenses help us to see, zoom in, and focus light, making them super useful in science, medicine, technology, and everyday life. Lenses in eyeglasses correct vision problems like nearsightedness and farsightedness. Magnifying glasses, microscopes, and binoculars use lenses to make tiny or far away things look bigger and clearer. Cameras and projectors use lenses to focus light and create sharp images. And telescopes and microscopes use lenses to help us see things too small or too far from the human eye. There are 2 types of lenses: concave, otherwise known as divergent lens, and convex, also known as converging lens. Convex lenses. Convex lenses are thicker in the middle and thinner at the edges. They bend the light rays inward, causing them to meet at a point called the focus. They are used in magnifying glasses, cameras, eyeglasses for far-sighted people, microscopes, and telescopes. They also produce real images. While concave lenses are thinner in the middle and thicker at edges. They bend the light rays outwards, causing them to spread apart. They are used in peepholes for doors, laser beams and some types of flashlights, and eyeglasses for nearsighted people. They also produce virtual images. Terms used with lenses. The optical center O of a lens is a point at the center of the lens through which all rays pass without deviation or bending. The principal axis of a lens is a line that passes through its optical center and is perpendicular to the faces of the lenses. The principal focus F of a lens is a point on the principal axis through which all rays parallel and close to the principal axis converge. This happens with convergent lens, or from which they appear to diverge after passing through the lens, and this happens with diverging lens. The focal length f of a lens is a distance between its optical center and its principal focus or focal point. The focal plane of a lens is the surface perpendicular to its principal axis and containing its principal focus. An object's size can be magnified using a magnifying glass. A magnifying glass consists of a convex lens held in place by a metal rim attached to a handle, while some are made entirely out of plastic. Magnifying objects or specimens allows observers to explore the world from a smaller, microscopic perspective, bridging the gap between that hidden world and our everyday experience. Magnification refers to the ratio between the size or distance of the image and the size or distance of the actual object, where magnification is equal to image height divided by object height, or distance of image from lens divided by the distance of object from lens. Real and virtual images. Knowing the difference between real and virtual images helps us understand how the things we use to see better or more actually work? For instance, why can't a magnifying glass project an image onto a wall? Why does a projector need a screen? And why can't you just look through a microscope and see a picture on your hand? If the image can be projected onto something, for example, a screen or a wall, it is a real image. If it can't, if it only appears to be there when you look through something, it's a virtual image. We need to know about real and virtual images because they help us understand how lenses work in everyday tools like cameras that form real images on films or sensors, projectors which shine real images on screens, magnifying glasses which create virtual images to help us see tiny details, eyeglasses and contact lenses which correct vision using real or virtual images, microscopes and telescopes which often combine real and virtual images to see very small or very far things. Real images are those produced at a point to which light rays converge, while virtual images are those produced at a point from which light rays appear to diverge. Examples of where real images and virtual images are produced and what produces them. Real images are produced on the retina, in a camera, and on the screen at the cinema, while virtual images are produced in a mirror, by a convex lens acting as a magnifying glass, and by a concave lens. Properties of real and virtual images of real objects. Real images formed by lenses can be seen on a screen, are produced by the convergence of rays, are located on the side of the lens opposite to the object, and are inverted or upside down, while virtual images formed by lenses cannot be formed on a screen, are produced due to divergence of rays, are located on the same side of the lens as the object, and are erect or right side up. Characteristics of the image formed in a concave lens. The image is smaller than the object. The image is on the same side of the lens as the object. It is closer to the lens than is the object, and it is virtual and erect. Characteristics of the image formed in a convex lens. The image is produced on the opposite side of the lens when the object is placed to the left of the focal point. It is closer to the lens than is the object. It is real and it is upside down. The lens formula. This is the lens formula. It is used to calculate the relationship between the object distance u, the image distance v, and the focal length f of a convex or concave lens. The lens formula is used to locate the image formed by a lens, to determine if the image is real or virtual, magnified or diminished, and upright or inverted, and to solve problems in optics involving cameras, glasses, magnifying glasses, and other optical instruments. Convex lens, converging. The focal length is positive. It can form real or virtual images depending on where the object is. Well, for concave lens, which are diverging, the focal length is negative and it always forms a virtual image. If you ever have to calculate for V and it is negative, then the image is virtual. And if it is positive, then the image is real. Comprehension. What do lenses do to light? And why do we use lenses? Lenses bend or refract light. It either causes them to converge or diverge. Lenses help us to see, zoom in and focus the light, making them super useful in science, medicine, technology, and everyday life. What is the name of each of the lenses A and B below, and explain what they're used for? A is a convex or converging lens. They are used in eyewear for far-sighted people. B is a concave or divergent lens. They are used in eyewear for nearsighted people. Label A through E. A is the focal plane, B the optical center, C the principal focus, D the focal point, and E the focal distance. Very good if you got all of them correct. Fill in the table indicating whether a real or virtual image will be produced by the device. Did you get them correct? So, a camera and a projector will produce real images, while a magnifying glass and a mirror will produce virtual images. Fill in the table with some properties of real and virtual images. Do you remember them? Did you get most of them? Congratulations! Properties of real images. Real images can be formed on a screen. They're produced in the convergence of rays. They're located on the side of the lens opposite to the object, and they're upside down. While virtual images cannot be formed on a screen, they're produced due to the divergence of rays. They're located on the same side of the lens as the object, and they're erect. What is the height of the object if its magnification is times 10 and its image height is 5 centimeters tall? Use the equation magnification is equal to image height divided by object height. You may use the triangle below to help you with transposition. Okay, so all you had to do was to take your hand and cover the object height, which is what we're looking for. And that tells us that we have to divide the image height by the magnification. So 5 centimeters divided by 10 is equal to 0.5 centimeters. That is the height of the object. Very good if you got this answer. Using the lens formula, answer the following equation. An object is placed 10 centimeters in front of a lens. Its image is produced 20 centimeters away. What is the lens focal length? Okay, first what we do, we want to list everything out, as we can see here, and then we want to substitute what we have listed out into the equation. We get 1 over f is equal to 1 over 20 plus 1 over 10. We find a common denominator, which is 20, and so we're going to multiply this 10 by 2 and this 1 by 2. Therefore, we're going to have 1 plus 2 divided by 20. That gives us 1 over f is equal to 3 over 20. But that is not all. We still have to transpose, where we flip. We flip the 3 over 20 to 20 over 3, get rid of the 1 over f, and we see we have 6.7 centimeters as our answer. The eye. What happens when light enters the eye? Light enters the eye via the cornea first. The cornea bends the light to help focus it. It then passes through the pupil, but the pupil controls how much light enters. The pupil is a porthole for light entering the eye. The lens fine-tunes the focus by changing its shape, while the vitreous humor helps guide light to the back of the eye. The retina receives the light and the rods and cones detect it. Then the optic nerve receives the light signal, which is converted to electrical signals and passes it to the brain. The brain processes the signals and gives you the ability to see. Here, energy is conserved as light energy is converted into electrical energy. The image that is formed on the retina is real and inverted. The brain flips the image right side up. Parts of the eye. Cornea. This is the clear, curved front surface of the eye that bends or refracts light as it enters the eye. It does most of the eye's focusing. It has a fixed focal length. Iris. This is the colored part of the eye that controls the size of the pupil. It helps adjust to bright or dim light. Pupil. This is the opening in the center of the iris that lets light enter the eye. It looks black because light goes in and does not come back out. Lens. This is a flexible, transparent structure that fine-tunes focus by changing its shape. The lens of the human eye are converging lens. It works with the cornea to focus light on the retina. It has variable focal length. Ciliary muscles. These control the shape of the lens for far and near vision. They relax to flatten the lens for distance and contract to thicken it for close-up. Retina. This is the inner layer at the back of the eye that contains light-sensitive cells, cones and rods. The cone cells allow us to see in color, while the rod cells allow us to see in black and white. Images are formed upon it. They're inverted and hence real. It converts light into electrical signals that are sent to the brain. The optic nerve. It sends visual signals from the retina to the brain. It creates the blind spots because there are no receptors where it exits the eye. Sensory ligaments. These connect the lens to the ciliary muscles. They help change the shape of the lens during focusing. Aqueous humor. This is a clear watery fluid in the front chamber of the eye between the cornea and the lens. It maintains pressure, nourishes the cornea and lens, and removes waste. It is regularly replaced like windshield washer fluid. Vitreous humor. This is a thick, jelly-like substance filling the space between the lens and the retina. It maintains the shape of the eye and keeps the retina in place. Sclera. This is the white, tough outer layer of the eye. It protects the inner parts and gives the eye its shape. Fovea. This is a small pit in the center of the retina. The sharpest, clearest vision comes from here. It is especially important for reading and detail. It is packed with cone and rod cells. Choroid. This is a dark, pigmented layer between the retina and sclera. It absorbs stray light and contains blood vessels that nourish the retina. It also helps prevent glare and visual distortion. Ocular muscles. There are 6 of them that are attached to the outer eye. They control eye movement in all directions, up, down, side to side, and rolling. They help to track moving objects or read smoothly. Eye defects. Short-sightedness. People who are short-sighted can see near objects clearly but cannot focus the light from distant objects. This is because the lenses in their eyes are refracting light too strongly. This makes the rays of parallel light focus in front of the retina. To rectify this, spectacles or contact lens made of concave or diverging lens are used to bend the light outwards before they enter the eye. People often wear these type of spectacles when driving. Short-sightedness is also known as myopia. In short-sightedness, the eyeball is too long and faraway objects are blurry. Long-sightedness. People who are long-sighted can see distant objects, but close-up objects are blurred. This is because their lens cannot bend the light inwards enough to focus the rays on the retina. Long-sightedness is also referred to as hyperopia. Near objects are blurry and the eyeball is too short. To rectify this, spectacles or contact lens made of convex or converging lens are used to bend the light inwards before they enter the eye. People often wear these type of glasses for reading. In summary, in short-sightedness, also known as myopia, the eyeball is too long, the lens in the eye is too strong, the image forms before the retina, and to correct it, you need concave lens. Whereas, in long-sightedness, also known as hyperopia, the eyeball is too short, the lens in the eye is too weak, the image is formed after the lens, and to correct this, convex lenses are used. Astigmatism. Astigmatism is a growing problem in Caribbean countries. This is where the cornea or lens is not the correct shape because it is poorly curved. It can result in blurred vision and long or short-sightedness. Astigmatism can usually be corrected by using toric lens. A toric lens is a spherical, curved lens designed to match the unique shape of your eye. The curvature is carefully tailored to match the degree of astigmatism, how uneven the cornea is, and the axis or orientation of that irregularity, which direction the distortion runs. However, in severe cases, surgery, for example, laser eye surgery, example LASIK or PRK, on the eye is necessary. Protection for the eyes. People are encouraged to wear sunglasses with ultraviolet protection in the sunshine. People are also encouraged not to look directly into the sunlight or luminous sources. Sunlight contains ultraviolet light which can damage the front part of the eyes, for example the cornea. Very bright light can damage the retina, which is found at the back of the eye. Comprehension. Which part of the eye does light cross first? And which part of the eye is colored? Light crosses the cornea first, and the colored part of the eye is the iris. What is the black circle in the eye called, and where does the image form in the eye? The black circle in the eye is called the pupil. The image forms on the retina of the eye. Are images in the eye real or virtual? Explain. What nerve transports the image to the brain, and what does the brain do to the image? The images in the eye are real because they are produced by a convex lens and they are inverted. The nerve that transports the image to the brain is the optic nerve, and in the brain, the image is flipped right side up for the brain to interpret. What is myopia, and what type of lens are used to correct it? This is when the eyeball is too long and the image is formed before the retina. Concave lenses are used to correct it. What is hyperopia, and what type of lens are used to correct it? Hyperopia is when the eyeball is too short, and convex lenses are used to correct hyperopia. What is astigmatism, and what type of lens are used to correct it? Astigmatism occurs when the cornea is not formed properly because of poor curvature. Toric lenses are used to correct this, and if it is too severe, surgery is carried out on the eye. Why should we protect the eyes from too much light, and how can we protect our eyes? Too much light in the eye can damage the cornea, retina, and the rod and cone cells. Hence, it negatively affects our ability to see clearly. We can protect our eyes by not looking directly into the sun or bright luminous sources. You can also wear specialized eyewear that protects your eyes from ultraviolet light. Label the parts of the eye, A through G. Did you get them correct? Awesome! A is the optic nerve, B the retina, C the cornea, D lens, E pupil, F iris, and the G ciliary muscles. That's all, folks. Thanks for joining me on this journey about light, the behavior of light, and the eye. Bye now.